Hi, this is Miss Downey with day 2 of our ellipse lesson, and today I would like for your bell work to be to read this paragraph and understand it, copy the graph to the right of it, and label this graph. Okay, so don't write all the words here. I'm going to give you 4 minutes and begin now. I will read this aloud. It says, since the co-vertex P of 0b is on the ellipse, the segment PF1 and segment PF2 is equal to 2 times A. If you denote the distance from each focus to the center of the ellipse by C, then A, B, and C are the lengths of the sides of a right triangle as shown in the ellipse at the right. Thus, the distances from the center to each vertex, to each co-vertex, and to each focus are related by the Pythagorean theorem. A squared equal B squared plus C squared. So, if the points positive negative A comma 0, 0, positive negative B, and positive negative C, 0, are vertices, the co-vertices, and the foci of an ellipse respectively, then C squared equal A squared minus B squared. Okay, so this is what our lesson's all about today. Okay, so if you will copy this graph to the right now and label it with these labels, that would be great. So do that now. Now while you're doing that, I will just speak. What they're saying is they're going to use the Pythagorean theorem to come up with more equations for us to work with these ellipses. And notice that now they're talking about line segments, PF1 plus PF2, and if you take the lengths of these, F1 and F2, it's equal to 2 times A. So A and A, so you've got one segment is A, length A, and the other segment's length A, so you've got 2A when you take the lengths of these from P to the focal point and P to the focal point. And this P is our co-vertex. So the distance from the P to our focus points are the same. So if we can get this distance, we just take it as getting A and multiply it by 2. And that's what we're going to use to work the next few problems. We've got 1 more minute. And while we're wrapping this up, I just want to point out they're using the Pythagorean theorem because we're working with right angles, because the axes are right angles to each other. So you've got the major axis and the minor axis, right? So they're at right angles, so you can use Pythagorean theorem to get the hypotenuse length and tell us more things about these things. Okay, so we're going to move on now. So our first problem I'm going to just demonstrate by doing a workbook problem. So make sure you've got your workbook out and your notes open, and we're going to work problem 7 together. Actually, I'm going to teach with problem 7, and then you'll work 8 and 9. Okay, it says find the distance between the foci of an ellipse. The lengths of the major and minor axes are listed respectively. So I like to note that the major axis, that's the first one, and I like to do this, major. Okay, and then the minor I do with the little m. Okay, so my major axis is 26 and my minor axis is 24, and we don't know which way it's going. Do we care if it's horizontal or vertical? Well, right now we don't know. So what we're going to work with is just these lengths. So we know if this is the length of an axis, that means, well, then the halfway point of this, right, to get to the center is to divide it by 2. So we'll call this F1 and this one F2. So we know that that half of our major axis is 13 and half of our minor axis is 12, right? So then there's our A and that's our B. So now we can apply the formula for this, right? So we can say c squared equals a squared minus b squared. And now we can start solving that by saying c is equal to the square root of a squared minus b squared. So I'm going to scoot this down, okay? And now we know a and we know b, right? It was half of those. So a is our major axis, so 13 minus 12. So it's going to be c is equal to the square root of 13 squared minus 12 squared, right? Which is equal to 169 minus 144, which is equal to the square root of 25. And so if we know that c, the square root of 25 is 5, so we know that c is equal to 5. And we know that it's 2 times c, right? So our answer is 10. That's how you do it. So if you will now work 8 and 9, I'm going to give you 3 minutes and then we'll move on. And I'll put this example back up. Let's see. It's sort of hard to see it. I don't know if I've got it all in there. Let's see if I can shrink it down. Nope, I don't. There we go. All right. There it is, and I will start the timer for 3 minutes. There you go. Make sure you're showing all your work. Time's about up. And let's move on. Okay. If you have time left at the end before we turn in our papers, you may finish in class. So let's continue with our lesson. Okay, so problem 4, and now we're on the back side of our paper. Okay, so problem 4 says, what is the standard form of an equation of the ellipse shown? And so here's the picture. So take a look at this, and we need to look that we've got foci here at negative 5, 0, and 5, 0. There's our focus points. And we know that this is a major axis because this one's longer than this one. So this is a horizontal ellipse. That means our major axis is horizontal. Thank you. And now we've got the foci are on our x-axis. That's what I just said. Sorry, I had someone in the room. Okay, so now, C is equal to 5, right? So that means that our distance from the center to the focus point is 5. So C is equal to 5. And A, that's the distance from the center to the end of our major axis, that's 8. See, it goes 8 in this direction and 8 that direction. So that's our A. And so that's all we need right now. It's our C and our A. So our C squared is 5 squared, 25, and A squared is 8 squared, which is 64. So now all we do is take our formula, C squared equal A squared minus B squared, and substitute. So C squared was 25 equal A squared, which was 64, minus B squared. And now just substitute, well, we just substitute. Now let's just solve. So subtract 64 from each side. And then fix our negative signs, because you would have had a negative 39 equal negative b squared. So that comes out to positive, positive. So b squared equal 39 is what we end up with. And so now all we have to do is write our equation, the x squared over a squared plus y squared over b squared equal 1. So there's our standard form of a horizontal ellipse, what we started with yesterday. And now substitute 64 and 39, because see, we got our b squared. That's why we were doing all this, is to get our b squared. Now we've got our standard form of an ellipse. Okay, so we use that Pythagorean theorem-ish formula to get to this, to give us our b squared, which let us put in our numbers and create our equation. Okay, so let's do our first problem together. So let's look at number 10 in the workbook. Okay, so here it is. It says write an equation of an ellipse for the given foci and co-vertices. So what you're going to work now, we'll work 10 together, then you'll do 11 and 12 on your own. So they give us foci is 0, positive, negative 3, and co-vertices is positive, negative 1, and 0. So the foci are on the y-axis, so the major axis is vertical. Because see, when you look at this, you've got the foci, that's the focus points at your major axis at 0, positive, and negative 3. So here, there's 3 and negative 3. So that's your long one, right? That means this one's going to be at 1 and negative 1. Okay, so it is a vertical ellipse. So we know that this is C, right? And this is B. So now C squared is equal to 9 and B squared is equal to 1. Now plug it into your formula. C squared equal A squared minus B squared, and C squared is 9 and B squared is 1. So we get 9 equal A squared minus 1. We'll subtract 1, or add 1 to each side. And what do we get? 10 equal A squared. So A squared equals 10. We'll just turn it around. So now we can write our equation. So remember, this is for vertical. So it's x squared over b squared plus y squared over a squared equal 1. So we know our a squared, right? And it is going to be 10. And our b squared, which they gave us in the beginning, is 1. See, b squared. So our final answer is x squared over 1 plus y squared, and that's y squared if that came out y2 over 10. Okay? And equal 1, and that's our answer. And that's how you work these. So if you'll take the next probably 2 minutes to do 11 and 12, about a minute apiece, we'll do that, and then we'll move on. We'll begin now. Okay, so I've written in some things here if you're stuck or having trouble getting started. So on 12, you've got to look. Let this finish out. So on 12, you've got to look and decide, is this horizontal or vertical? So when you plot these, foci is at 0, positive, negative 4. And the co-vertices, oh my goodness, what does it say? 4 and negative 4. So what do we have here? It would be a circle. But for the sake of our assignment, we're going to call this vertical. Okay? So just use your vertical in the case of a circle. So your second step is to find A, B, and C. So we know that C is equal to 4 and B is equal to 4. All right? So what is A? So you're going to go C squared equals A squared minus B squared. And we know we've got what? C and B, both 4. So C squared is going to be 4 squared equal A squared minus 4 squared. So you have 16 equal A squared minus 16. So what happens here? So we're going to add 16 to each side. and then plug it into your final formula. So your standard form is going to be x squared over b squared plus y squared over a squared equal 1. And I'll let you finish that out. 2 seconds here if you haven't. And we're going to move on. Okay, so number 13, I'm going to save that for you to work at the end. Okay, it says the decorative arch of a bridge is shaped like an ellipse. The arch is 120 feet wide, so that means what? From there to there, it's going to be 60, right? And it says the foci are 48 feet from the center. So that's going to be at 48 and negative 48. So what is the height of the arch? So what are we missing? Right? So if we were to extend this, what would we have? Well, just from looking at it, it looks like we have a horizontal ellipse, but can we prove it? So I'm going to leave this for you to work out, and for right now, let's skip that and move on to the next problem, and we'll finish this assignment. Okay, so there's no more direct instruction. This is a lot like problem 2 that we worked yesterday. This is find the foci for each equation of ellipse. So let's work 14 together, and then I'll let you work 15, and then we'll work 16 together, and then I'll let you work 17, and then you'll go back to the word problem, and that's it, okay? So let's look at number 14. Find the foci for each equation of an ellipse. So what they're asking us is, they give us 9x squared plus 18y squared equal 162. So just like we did, we've got to turn this into 1. So we need to divide everything by 162. Okay, and when we do, we get, this cancels out, so you get x squared over 18. Oh, that's a mess. Let me write that again. X squared over 18 plus, and this simplifies to y squared over 9 equal 1. So now we need to identify the foci, right? So we've got our equation. So we know, because this one's bigger, that this is our A, right? And that means this is our B. So that's our A squared, and this is our B squared right there. Okay, so we know that C squared, which is what we're looking for, our foci length, is equal to A squared minus B squared. So now just fill it in. So we know our A squared is 18, and we know our B squared is 9. So we know C squared is equal to 18 minus 9, which is 9. So C squared equal 9. And now take the square root of each side, and then you get C is equal to 3, positive negative 3. So because this is a horizontal ellipse, it's going to be 3, 0, and negative 3, 0. And those are our foci. And that's how you work these. Okay? So now I want you to do the same thing for number 15. I'm going to give you 90 seconds, and then we'll move on. step is to clear out this to go to 1. So divide everything by 1600. Right? So 10 seconds, and just remember this one's bigger, so this one must be vertical. That means this is my A squared, and then that's my B squared. Right? So plug it into your equation. C squared equal A squared minus B squared, and solve for C, and tell me your foci. Okay? All right, so now we're going to move on to the last problem. Okay, so for our last problem set, we're going to work 16 together, then you'll do 17, and then spend the rest of your class hour on the word problem on number 13. Okay, so let's focus on 16. It says write an equation for each ellipse. Well, we can tell by looking at this, it's longer. So this is a horizontal ellipse. And that's at 3, and that's at -3. And this is at 2 and -2. So our A value is equal to 3, and my B value is equal to 2, right? A is my major, B is my minor. So that length is 3, this length is 2. So now we're going to plug that in to our formula. X squared over A squared plus Y squared over B squared is equal to 1. And now plug it in. A is equal to 3, so it's going to be x squared over 3 squared plus y squared over, and b is equal to 2, so 2 squared equal 1. And now to simplify. So it's going to be x squared over 9 plus y squared over 4 equal 1. And that is your formula. And that's how you do that. Okay, so now work the last problem, 17, and then go back and finish number 13. And that will conclude this lesson. You have a good amount of time to finish anything you haven't finished. And at the end of the hour, last 5 minutes, everybody pass your papers forward and then down the front of the rows in alphabetical order. And then it will all migrate to the first row, first person, and that person hand your stack of papers to the substitute if I'm not here. And if I'm not, I will return Monday, and I will see you then. This concludes our lesson on ellipse, and we've got one more lesson on hyperbolas, and then we'll be through with this chapter. And this concludes our lesson. Thank you very much.